Good afternoon, welcome back to the Thermodynamics basics. Today we will see the spontaneity and other important parameters. Whereas the bond energy, bond enthalpies and all the very normally questions are not being asked in the MSETs or the NITs and all. We will see in the last. So spontaneity is not defined by first law of thermodynamics. That is meaning you want to say direction of the flow, direction of the heat flow is not mentioned in first law of thermodynamics. So normally what happens in the spontaneous, we conclude generally, there is general, means not the scientific this thing. Heat is flowing from high temperature to low temperature, and the gas is flowing from high pressure to low pressure, water is from the high elevation to the low elevation, like this we call, and it is called unidirectional. Unless otherwise you are giving a energy or work, it will not be, it cannot be reversed. So now, so it is initially it was defined like the spontaneous. So anything further developments, there are so many further developments. The first development is suppose if water is formed, means hydrogen and oxygen, if I am keeping aside, will it be spontaneous reaction? It will form a water immediately? No, it will take many number of years to form. Can I say it is not a spontaneous? No, it is a spontaneous reaction. So that, but it is very slow. That will be in dealing. It can be dealt in chemical kinetics, but it is a spontaneous reaction. So how to make it that it is a spontaneous or not? So then immediately somebody told that enthalpy, if it is from the enthalpy point of view, we can define the spontaneous. That's what the people first initially, yes, it is to some extent spontaneous reactions are an irreversible processes. That is the first irreversible process are irreversible is spontaneous. To some extent, at least around 80% it is correct, spontaneous, right? Now, is it not fully correct? Now there is a further development, enthalpy. So if I am taking N2H2 reaction, that means ammonia formation, ammonia gives H2 plus N2, half N2 plus 3 by 2 H2. This delta H reaction is equal to minus 46. And another reaction, if you see hydrogen chloride, hydrogen plus chlorine gives a Cl, means half hydrogen and half chlorine formation if I am taking. Delta H reaction is equal to minus 92 something kilojoules per kilo, units and all you write, kilojoules per mole, kilojoules per mole. And another reaction, if you see hydrogen plus oxygen of O2 gives H2O. This also delta H reaction is negative. I am not writing the values. Then if you see the nitrogen plus oxygen, half nitrogen gives NO2. Yes, delta H is positive. So I am stopping here. Now first three equations you see. So from this it is all exothermic reactions are the spontaneous reactions, right? So here from our theory we say this is a delta H is positive, that means it is endothermic reaction. Endothermic reaction means it is non-spontaneous, but statement is wrong. First three statements is correct, means all this is also spontaneous. So again one more break has come. So enthalpy also not able to define properly the but it contributes. Majority cases, miss from 70 to 80%. Now irreversible is already defining around 70%. Now we are further developed. Enthalpy, yes, most of the cases of the exothermic reactions, enthalpy, it is a spontaneous reaction. Now what else? Then finally it is concluded that one more term we have to introduce, that is called entropy. This is most important in the spontaneous reactions. Entropy is introduced, its symbol is S, and the change in entropy is delta S. Normally all the time we are seeing this delta change in entropy, change in enthalpy, change in temperatures, all these things are change only we are measuring. Now what is this change in enthalpy, entropy? Entropy is nothing but defined as the increase in the randomness. Increasing the randomness is called increasing the increasing randomness is entropy defined. Change in entropy we are called. So this means by giving heat to a system, its entropy is increasing, but the rate also, the temperature rate at which we are feeding to the system is also most important. That means for a given quantity, if I am increasing the temperature very fast to a system, and in another case I am increasing the temperature very slow, the second one is giving more entropy. But so finally what I am defining, delta S. Delta S equal to Q reversible by T. Q reversible by T. Now here again there is a small break. The break is iron, rusting of iron. Everybody knows Fe plus O2 gives Fe2O3. Fe2O3, 2 Fe, 2 O3 balancing if I am doing, 3 O2 and 2 Fe balancing, and delta H reaction of the this thing standard equal to in this not a reaction is entropy change equal to delta C equal to minus 549. When delta S is what we are saying, delta S should be positive. Then here delta S is negative. There is no spontaneity. How the rusting is taking place? Then here there is small correction we are applying in the delta S. Delta S system we are modifying into the delta S system plus delta S surroundings. Meaning of that is, so delta S total we are defining. Delta S total equal to delta S system plus delta S surroundings. If it is more than 0, it is spontaneous. Finally, spontaneous we are able to define on entropy. In delta S is a change in entropy, but that will be taken as a total. Total it means delta S system plus delta S surroundings. Even system may be negative, but surroundings is total is more than this. In this case, system is negative, but delta S total is more than the 0. So rusting of iron is possible, or it is a spontaneous reaction. That will be normally asked, generally asked question. Delta S is negative for a system, but it is a spontaneous reaction. Say how it is possible, or they tell the reasonableness. This is one small this thing. So finally delta S system equal to Q system reversible by T, that is different. Now, okay. Now one small interesting this small what you call we'll see whether it is the how you understood the, or it is better to understand for entropy. We'll see some small examples. Liquid is water. Liquid you can take as a liquid to vapor. It has become steam. Now what is the entropy change? What is increasing or decreasing, or no increase or decrease? No. Liquid is means slightly ordered compared to the vapor. So from orderliness to randomness has increased. So entropy is increased. Okay, it is very clear cut. So okay. So or some people say 0 to solid ice means ice to water, entropy is increasing. Now one more of this thing, a solid ice is there at minus 20 degrees centigrade. It is further taken out from the fridge and kept outside for some time. It will not be directly given the values, but it is still ice. It is still ice. Temperature I am not mentioning, but a solid is taken out from the fridge at minus 20 degrees centigrade, but still I have whatever the ice cubes are ice cubes. Now whether entropy has increased or not, like that, this is a one more question. No, entropy is increased, because though it is some temperature minus 22, it might have come to minus 10 or minus 8, or, but it has not come down to the 0 degrees. It ice has become, so orderliness has increased, but not. So here also entropy is increased. Now one more this thing, a solid is more orderliness, or entropy is less. Calcium carbonate you take. Calcium carbonate has become decomposed to calcium oxide plus CO2 gas. In this reaction what happened? Decomposition of calcium carbonate is entropy increased or decreased. So this solid Calcium oxide is also solid. Calcium carbon dioxide is gas. So a part is become gas, that means entropy is increased. Immediately you have to say entropy is increased. Okay, fine. One more example we'll see. So one example, chlorine gas has become 2 chlorine atoms gas. Both are gases. How you will say here the entropy? Entropy, a diatomic molecule has become the monatomic molecule atom. So here also entropy is increased. The reverse is reverse. Tomorrow we will see some problems and all. Okay, thank you.